Find the coordinates of the inflection point of the logistic function. This is the general form of a logistic function. As a graph, what a logistic function does is it has exponential growth at first, but then at some point that growth starts to slow and plateau so that it approaches what's called an upper limit. The upper limit has a value of L. There's also an important point where the logistic function crosses the y-axis. The coordinates of that point will be 0, f of 0, often called the initial value, whereas L is the upper limit. It just so happens that for all logistic functions, the point where we have the steepest growth, so this is the steepest part of the slope, that point is called the inflection point. And our job in this question is to find out what its coordinates are. So one fact we can use to help us solve this is the inflection point of a logistic function always has a y value of L over 2. It occurs halfway to the maximum value of L. So the y coordinates of that inflection point are going to be L over 2. So what I'm going to do is I can now solve for the time that this occurs by plugging into the logistic function. You want to let your y value equal L over 2, and you're going to plug that in on the left side of the function for f of t. So let's see what that looks like. At that point, you want to solve for the time of the inflection point. So I would take this entire denominator here and multiply it to the other side. The L's will cancel because you have one on the left and one on the right. Now I'd multiply that 2 to the other side. Next step would be to subtract 1 from both sides. Now we'll divide by A. At that point, we want to take an ln of both sides of the equation. ln and e cancel. Now I'll divide by negative k. This reveals the time at which the logistic function has its inflection point in terms of a and k. The time is negative ln 1 over a divided by k. Now sometimes you may see this in a simpler form. What we could do is use the rule of an ln of a fraction can be rewritten anytime we have ln of, say, x over y. according to log rules, that could be ln x minus ln y. So that could be used here. Ln of 1 is going to be 0. And that reveals a little bit simpler version of the time, which would be ln A over K. So now we know that the horizontal value here of the inflection point is going to be given by ln A over K. Sometimes we might see this same problem in a different form. Logistic functions can often be expressed as being in the form of L over 1 plus AB to the negative t. So we could find the general coordinates of this inflection point using the letters L, A, and B instead of L, A, and K. The same principles apply. You want to let the function's value be half of the carrying capacity, or half of the upper limit. Plug that in on the left. And we should now be able to solve for t. So I'll multiply the denominator to the other side. Cancel the L's. Multiply by 2. Subtract 1. Divide by A. Take a natural log of both sides. This allows the exponent to come down in front. And now we can divide by ln b on both sides. And we have our answer. We could simplify that just a little bit. It looks like t occurs at a value of ln A over ln B. So if we had a function that looked like this, a logistic function, whose formula was L over 1 plus AB to the negative t, then the inflection point would occur at half of the upper limit, and the coordinates of that point would be ln A over ln B, comma L over 2.